Some of you may speak more than one language, and all of you, in principle, are able to speak more than one language. So, bilingualism is an increasingly common feature that's represented in our cognitive system, and cognitive scientists have wondered how it is that multiple languages are actually represented within the same brain. So, you can ask how one's thought processes in one language are influenced by the ability to comprehend, produce, and think in another language. And of course, there's been a good bunch of research on this. Some general findings based on this research are the following. So, if you look at some general effects of bilingualism, if you look at children and adults, they actually tend to outperform monolinguals, those who only know one language, in other cognitive control measures as well. And we'll talk about why that might be the case. But the sheer fact that you have to juggle two or more languages in your brain has some benefits that extend beyond just language learning. So the thinking is basically that if you think about the regular use of two languages or more than two languages, there has to be some mechanism in your attentional system that actually makes that you're selecting one of the two languages and make sure that the other one doesn't come out. So right now, for example, for myself, I know English and I know Dutch, and it's not the case that every other word that I'm speaking is Dutch and then a word in English and then a word in Dutch, right? So there's got to be some sort of mechanism somewhere that selects one of the two and then actually inhibits the other language from coming out. Now, we could ask why exactly it is that there's enhanced cognitive control in more general tests than just bilingualism. And one possibility is that this really stems from the conflict between selecting two or more languages. But the other possibility is that it's even more specific than that. It has to be two languages that are both expressed through the same modality. And what I mean by this is the following. I speak two languages. I speak English and I speak Dutch. Those two cannot come out of my mouth at the same time. That's physically impossible. However, there are also people, plenty of people, who know one spoken language, say English or Dutch or French or whatever, Spanish, and they also know a sign language. And it may be that in that case, even though they know two languages, because they can use their hands to express the sign language, and they use their mouths to produce the verbal language, the spoken language, maybe in that case you don't actually get the cognitive benefits. So the question is really, is this about just two systems being active? Or is this specifically about control and conflict and inhibition with respect to producing these two languages through the same modality? So this is what our last paper is about, and it's entitled The Source of Enhanced Cognitive Control in Bilinguals, Evidence from Bimodal Bilinguals. And bimodal is a word for speech and sign language. Okay, so we're going to compare those who speak multiple languages to those who speak only one language, monolinguals, to those who speak, quote unquote, more than one language, one of them being a spoken language and the other one being a sign language. So those are bimodal bilinguals. Here's the abstract from the paper. So bilinguals often outperform monolinguals on nonverbal tasks that require resolving conflict from competing alternatives. The regular need to select a target language is argued to enhance cognitive control. We investigated whether this enhancement stems from a general effect of bilingualism, meaning just representation of two languages, or specifically from a modality constraint that forces language selection. Meaning if you speak two languages, you can only speak one at a time. So now there's an actual need for some sort of selection between the languages. Bimodal bilinguals can, but do not always, sign and speak at the same time. Their two languages involve distinct motor and perceptual systems, leading to weaker demands on language control. We compared the performance of 15 monolinguals, 15 bilinguals, and 15 unimodal bilinguals on a set of flanker tasks, and I'll explain what that kind of task is. There were no group differences in accuracy, but unimodal bilinguals were faster than the other groups. Bimodal bilinguals did not differ from monolinguals. These results trace the bilingual advantage in cognitive control to the unimodal bilinguals' experience controlling two languages specifically in the same modality. So That's the abstract. Now, what happened in this paper? Okay. First of all, they recruited those 3 groups: monolinguals, bimodal, and unimodal bilinguals, and they employ a bunch of measures to make sure that these groups are otherwise as similar to each other as possible. So, for example, they look at the amount of education these different groups have so that there's no differences there. They look at Catel's standardized score, which is an intelligence measure. There's no difference there. If you look at the bimodal and unimodal bilinguals, they rate themselves for English, their ability to produce English, their ability to produce non-English, so when they actually acquired their first language, and then years of speaking English. So you see, by and large, these groups on the most important measures are actually matched to each other. And then here's the flankers task. They have 5 different conditions. One is very straightforward and is a control condition because it doesn't involve a conflict. There's an arrow that either points to the right or to the left. If it points to the right, you push a button on the right. If it points to the left, you push a button on the left. That's a control condition. Then there's a go condition where they put some flankers next to it that are not terribly distracting, but somewhat, and the task is otherwise the same. And in this case, these flankers do indicate whether you actually need to act or not act. So this is a go, no-go condition, where if you see the squares, you act. If you see X's surrounding the arrow, you're actually supposed to not respond. So that's a no and a go and a no-go condition. And then they included 2 additional conditions: an either congruent condition, where all the surrounding flankers are pointing to the same response location, or an incongruent condition, where you have to ignore these non-red flankers and only respond to the pointing direction of the one red arrow that you see here. So that's the task. And in this task, you can look at accuracy, right? How well do people do this? Do they make mistakes or not? And you can look at their response time. And again, the idea is that the longer it takes you, the more difficult the task is. Finally, the key thing really is that now you can compare these measurements across the 3 groups of monolinguals, bimodal bilinguals, or unimodal bilinguals. So let me pause here for a second and just step back a little bit so you know what to do for the structure of your reaction paper. We got the 6 paragraphs. The first paragraph is broad introduction. So you could talk there about how the world has become generally more globalized, and that as a result of that, bilingualism is increasingly more common. How is it that people juggle different language systems within the same mind? Something like that. Second paragraph, what are the particular hypotheses? Oh, and in the first paragraph, you could start talking about unimodal versus bimodal bilinguals as well. Second paragraph, what are the hypotheses? One hypothesis is that there's an enhanced cognitive control benefit, otherwise known as the bilingual advantage, due to having to separate 2 representations of language systems in the brain. And according to that hypothesis, it wouldn't matter whether those 2 languages are of the same modality, meaning both spoken, or if they're from a different modality, meaning one is spoken and one is sign language. A second hypothesis is that it's specifically the overlap in modalities between 2 languages that actually causes people to have to control and inhibit one language, and that inhibition, that increase to actually control your speech at any given point in time, is what has given rise to the bilingual advantage. So those are the 2 hypotheses. Then in the methods, you can talk about how they recruited 3 different groups: a group of monolinguals who speak one language, a group of bimodal bilinguals who speak one language and know sign language, and a group of unimodal bilinguals who speak 2 languages. So that's the independent variable that's being manipulated. What's then being tested is the flankers task, where they basically look at a basic cognitive control measure, and then they compare these 3 different groups in terms of their response times. Fourth paragraph, what are the results? So here we go. The control condition, there is no significant difference, although actually it looks like, if anything, the bimodal bilinguals and unimodal bilinguals were a little bit faster than monolinguals. But more interestingly, if we look at the go and no-go task, unimodal bilinguals were actually in that case faster than bimodal bilinguals and monolinguals. So you see that those who did sign and speech were way more similar to monolinguals than those who speak two languages. And you see the same thing in the congruent response times and the incongruent response times. So those are the main results. And these results, for the implications in paragraph 5, seem to imply that the bilingual advantage really comes from having to juggle two languages that use the same modality. And that's reflected in the fact that unimodal bilinguals are actually better at these cognitive control tasks than bimodal bilinguals and monolinguals. So that's the paper. Now, then in your 6th paragraph, you can, of course, give your opinion on that. Let me say a couple more things that we know about bilingualism. So, well-known researcher by the name of Alan Bialystok is world famous for this work. She has shown that unimodal bilinguals are better than monolinguals at cognitive control tasks. So, for example, they're better at selective attention, they're better at inhibition, they're better at switching between different alternatives. And what's interesting too about this is that these advantages actually are maintained in older age. Bilingualism has been shown to help offset any age-related cognitive losses. So, for example, with respect to Alzheimer's disease is delayed the onset by about 4 years or so for unimodal bilinguals versus monolinguals. Unfortunately, the flip side of that is that once it does develop, it actually develops more intensively, more quickly. So it prolongs the onset, but then once it hits, it actually is more severe. For those of you who are listening to this and know that you only speak one language, you're a monolingual, of course you may think, well, this is great and all, but now what am I going to do? Well, fortunately, there's also been a good amount of work that shows that even when you start learning a language later in life, that people can actually get these benefits very quickly. So even if you start studying Spanish now or you start studying some other language, you can actually get these benefits in terms of staving off cognitive decline in a relatively short duration, even as adults. Which areas are involved when people are actually trying to deal with language switching? Well, again, it's an executive control process. So the dorsolateral prefrontal cortex, which we've seen so many times before already, is really the main area that gets activated when people switch back and forth between different languages. Finally, there's of course been work on the link between language and thinking. And the question is how knowing a particular language and knowing certain words in a certain language changes the way in which you see the world. And this has been a question since the times of Aristotle already. The ancient Greek philosophers were very interested in this, and basically they wondered how it is that, the way in which we speak influences the way in which we think. And it turns out that language processing influences many cognitive domains, actually. And some examples of that are color perception, spatial navigation, spatial reasoning, time perception, as well as number perception. So to give you one example of color perception, a researcher at the time in Maastricht, a German researcher by the name of Mitterer, ran a study where he realized that traffic lights in the Netherlands and Germany have different names for the different colors. So in the Netherlands, we have red, orange, and green. And in Germany, just like the United States, we have red, yellow, and green. So he wondered if you now show people images of that red or that yellow or orange color in the middle, and you ask them, you play around with the shade and how orangey or how yellowy it is, at what point do people switch between calling it yellow versus calling it orange, and is that different for Dutch people versus German people? And what he found was that for Germans, the light had to be way more orange for them to start calling it orange instead of yellow, because they associated that light in a traffic light with yellow. And for Dutch people, the exact opposite. It had to be way more yellow before they were willing to call it yellow instead of orange. So the way in which we label things actually influence color perception.